Okay, so if you recall, right, from before, we have three methods of doing AA similarity, SAS similarity, and then SSS similarity. Looking at the diagram and looking at all my information, okay? Just be very careful, read it. Let's see. Triangle ABC. Okay, so that means it's a triangle, okay? And D is a point on AB, AB being a line. Okay, I see that there. E is a point on AC. Again, I see it there. Okay, and then here we go. This here is the super important stuff because it actually gives me information. DE, and then if you don't remember what that notation means, it means parallel. So if you ever see two lines like this, it means parallel. Okay, so it means DE is parallel to BC. So what I can do is I can do little arrows there, and that's going to mean parallel. That right there is probably going to be the most important part of why these two are similar. Okay, why we can prove it. And so, all right, this is all the information we have. We have no numbers, we have no measurements, we just have the fact that we have parallel lines. So that already says SSS is out of here, and also SAS, because we have nothing for a side. We can't compare them because we don't have numbers. Now, if we were talking about midpoints or you're talking about like it bisects, then we can potentially talk about S, but there's nothing about that there. Okay, so let's go ahead and let's just think about it. We have parallel lines. Why is this so important? Well, if you remember from other, lessons or other videos, whenever you have parallel lines and you have a line that is going through both of them, it's called the transversal. And so then you have all of these other, relationships. You have corresponding angles, right? You have, let's see, corresponding angles, whatever. And then you have same side interior or same side exterior. You have alternate interior, alternate exterior, right? There's so many different names that people give it, but they're all the same basically concepts. So if you look at this, we're looking for angles that are congruent. Okay, so one thing that you can see is this angle right here is going to be congruent to that angle because they are corresponding. Okay, and pretty much the exact same thing, we're going to have these two angles also because they're also corresponding. So that there, we already have AA. Okay. For some of you guys that are probably thinking it too, if you notice this angle A here on the top is actually going to be found in both of the triangles when you separate them. So that actually can also be considered another A. Okay. So basically now all we have to do is just be able to write it in a very non-formal proof, okay? Because this here, if you were to write it in a formal proof, you're going to have to be like, these are parallel lines. And then you say they're corresponding. And then you say, because they're corresponding, they're congruent. All right, so it's just a lot of steps, but we're going to go ahead and take like, little shortcuts. So the first one I'm going to do is this A here, which is the one that I showed. And if you notice, it's going to be this one and this angle. So let's say angle ADE is congruent to angle, you got to be careful now. I will accept two different ones, right? I'll accept CBA, okay? But and I'll accept angle the other ABC, okay? The only thing I will not accept though is if you say angle DBC, because point D is nowhere in the big triangle basically, okay? So you gotta be very careful with it. Okay, I'll be very lenient with it, but not like as lenient. Okay, so let's see, ADE, because this one comes from, basically think of it like it has a smaller triangle and then it has the big triangle, the ABC triangle. So we'll call that one too, okay? So ADE is similar, or sorry, is congruent to CBA. Okay, that's fine. Doesn't matter if it's going different directions. And we know that's by corresponding. Okay, so corresponding angles. I'm just being very lazy there, but you get what it means. And then I can do the other one, which is going to be over here with the blue. So I'll say angle AED. Again, look how I'm being organized, right? The one on the left is going to come from the smaller triangle, and then the one on the right of the congruent sign is going to be for the bigger triangle, okay? So really try to stay organized. So AED, and then we're going to have angle ACB. Again, it's the exact same reason, right? By corresponding angles, okay? And so then we technically, right, this is what I like to do in my proofs, right? I like to do parentheses and just basically keep myself organized with there goes the A, there goes the A. And so technically we can really say that we're done because we already showed at least one of these three, which we showed by AA. So then we can say, so by AA similarity, we can say that triangle ABC is congruent to triangle ADE. Okay. Now I know some of you guys are saying, well, the one on the left has always been the one. It doesn't really matter. Okay. You're nitpicking now. Okay. And I'm not going to be super nitpicky, but there you go. Now just remember though, I skipped a lot of steps in this proof, right? First one, the whole given. The second one, since they're parallel, that means it's corresponding. And then after that, because they're corresponding, they're also congruent, so it's a lot of steps here, but you need to be able to do the gist of it, okay?